A few years ago, running a large language model required a data center. Today, quantized models under 4 billion parameters can run on a modern smartphone chip. Apple demonstrated this with on-device processing in Apple Intelligence. Google followed with Gemini Nano, designed to run locally on Pixel hardware. Qualcomm and MediaTek are shipping NPUs specifically built to handle transformer inference on mobile SoCs. This is not a fringe experiment anymore. It is a measurable engineering trend. And for anyone building applications where user data should never leave a device, this shift matters. Because it reframes a core tension in AI adoption, the trade-off between model capability and data exposure. The question is no longer whether edge inference is possible. It is whether the privacy gains are as real as they appear. To understand what edge-optimized LLMs change, you need to understand the default architecture they replace. Most LLM-powered applications today work through API calls. Your prompt leaves your device, travels to a remote server, gets processed, and the response comes back. That round trip means your input, whether it is a medical question, a journal entry, or a code snippet, exists on infrastructure you do not control. Edge-optimized models flip this. They are compressed versions of larger models, often using techniques like quantization, pruning, or knowledge distillation to reduce size and compute requirements enough to run locally. The key trade-off is capability. A 4 billion parameter model running on-device will not match the reasoning depth of a 70 billion parameter cloud model. But for many privacy-sensitive tasks, summarization, local search, text drafting, it may not need to. The privacy mechanism here is architectural, not policy-based. When a model runs entirely on-device, the data pipeline is short-circuited. No network request carries your input to a third-party server. No cloud provider stores your prompt. No logging infrastructure captures your conversation. This is fundamentally different from a privacy policy promising data is not retained. Promises depend on enforcement and trust. Architecture removes the need for trust by eliminating the data transfer altogether. Frameworks like MLX from Apple and llama.cpp from Georgy Jurganov's open source project enable this by making local inference practical on consumer hardware. Google's AI Core on Android provides a system-level runtime for Gemini Nano. These are not wrappers around cloud calls. They are genuine local execution environments. The result is that privacy becomes a structural property of the system, not a contractual one. That distinction matters for regulated industries like healthcare and legal services. 3 things worth noting. First, edge inference does not automatically mean full privacy. If an app runs a model locally but still sends telemetry, usage analytics, or aggregated outputs to a server, the privacy gain is partial at best. The model location matters less than the full data flow. Second, model updates introduce a subtle risk. If a model is fine-tuned locally with user data and then synced or federated, information can still leak through weight updates. Differential privacy techniques can mitigate this, but they are not yet standard in consumer deployments. Third, capability limits shape what privacy-first actually means in practice. A local model that cannot handle a complex task pushes users back to cloud APIs. The privacy-first application is only as robust as the local model's competence boundary. So the real question is not just whether inference runs locally, but whether the full application stack respects that boundary. Edge-optimized LLMs create a real architectural path toward privacy-first AI applications. Not a perfect one, but a meaningful one. The core advantage is structural. Data that never leaves a device cannot be intercepted, subpoenaed, or leaked from a server breach. But privacy is a system property, not a model property. A local model inside a leaky app pipeline does not deliver on the promise. For developers and product teams, the practical takeaway is this: edge deployment is now viable for a useful range of tasks. The gap between local and cloud model performance is narrowing with each generation of hardware and quantization technique. But building a genuinely privacy-respecting system requires more than just shipping a small model. It requires auditing the entire data path. If you find this kind of context useful, subscribe to the Latent Dispatch. We track meaningful AI shifts without the noise.